Morning students. Today we will learn about the first chapter of physics, electricity. So this is first class. Let me start with. So we learn about the chapter electricity. We learn about the chapter electricity. See, what is electricity? Electricity is nothing but you come across this electricity in your daily life. So in your home, you are using TV, you are using refrigerators. So these all are running on energy called electricity or electric energy. So what is electricity then? Electricity is nothing but it is the study of charges. This study of charges. What is electricity? Electricity is study of charges. This is a part of physics or a branch of physics which deals with the study of charges, that is called electricity. So this electricity has two types. Electricity has of two types. One is static electricity, another one is current electricity. So there are two types of electricity. One is static electricity, another one is current electricity. So we learn about what is static electricity and what is current electricity. So first we learn about what is static electricity. So what is static electricity? As the name suggests, static electricity means static means at the rest. Electricity means it is again the study of charges. So what we can say is the electricity which is static or study of charges at rest. The charges are at rest, we call it as static electricity. When the charges are at rest, we call it as static electricity. So, static electricity means what? Study of charges at rest. This is type of electricity which deals with the study of charges at rest. Static electricity. How to define? The study of charges at rest is called as static electricity. Static electricity means the study of charges at rest. We will learn about current electricity later. Then where is static electricity? Where do you use? Suppose if you take a plastic scale. If you are taking a plastic scale and if you have to rub it into your hairs. When you rub it into your hairs continuously, the atoms in that plastic gets charged. Means electrons and positive charges becomes charged, but they are at rest. So when you take the comb and you rub it to hair, then the charges in the comb become active. That means electrons and the positive charges becomes active, and after that immediately you have to bring it to some papers. Okay, here are papers. Let me say these are papers. Okay, if you bring it to these papers to the metal scale, then there will be attraction between the electrons and paper or positive part of the metal papers, plastic scale and the papers. Means in papers also there are electrons and there are positive charges which you can say protons. Okay, and in metal scale now I have seen the electrons gets charged. Protons or positive charges gets charged. So these negative charges will attract the positive charges of the paper piece, and the negative charge of the paper piece will attract the positive charge of the plastic scale. So hence there is a force of attraction between these two, which we can call it as static electricity. So this is regarding static electricity. What is static electricity? Let me repeat it once again. The study of charges at rest is called as static electricity. The study of charges at rest is called as static electricity. Whereas electricity is the study of charges is called electricity. The study of charges at rest is static electricity. So where we find static electricity, as I explained, if you have to take the comb and you have to rub into your hair, now the electrons in the combs gets charged, but they are at rest. These comb has to be touched in contact or nearly with the paper pieces. Now the atoms in the paper pieces, there are electrons present and positive charges are present. So that positive charges of comb will attract the negative charges of paper piece, and positive charge of paper piece will be attracted by the negative or electrons of comb. Hence there will be a force of attraction happens, and that is static electricity. And it is not much there for your syllabus. We are learning mainly current electricity in your 10th. Okay? So what is current electricity? Current in the means almost we can say it is in motion. Okay? Electricity, nothing but charges. The study of charges, in motion. Here it was study of charges at rest. This is the study of charges in motion. Current electricity is nothing but it is a type of electricity which deals with study of charges in motion. When the charges are in motion, then we can say that it is the current electricity. Current electricity is the study of charges in motion, whereas static electricity is the study of charges at rest. So how we come across this with study of charges in motion? Let me tell you. What about current electricity? That is study of charges in motion. Okay. Current electricity, as we already knew this, study of charges in motion. When the charges are in motion, then you have to learn about current electricity. That we can call current. Suppose if I take a conductor or a copper wire, this is connected to a cell. Cell you have already known of this. Okay, a wire is connected to a copper wire to a cell. So this is a conductor. Let me see. You can say a copper wire, a small metal piece or metal rod can be taken. Okay, see, conductor is there and here battery is there. Let me, in conductor, as you know, there are atoms. Okay, in between atoms there are electrons, free electrons. Okay, let me say only electrons. As you all know, there are atoms. In that atoms there are free electrons. Okay, free electrons in the sense, why they are called free electrons? Because they do not have any particular direction. They are moving in a random way. Those are free electrons. They are present in metal. As you have already learned in chemistry, metals are having free electrons at their last subshell. Okay. So when the battery is there, or cell is there, cell is there, when the cell is applied to a conductor, what happens? The negative side of the cell is having more number of electrons. Hence it is what? Negative side. Whereas the positive side is having positive charges, means less number of electrons. Okay? These electrons, okay, repel these electrons. Means these electrons are negatively charged, and the electrons present in the conductors also negatively charged. So the electrons which are negative charge will repel the electrons of the conductor. Repel means avoiding. Okay? Attract means coming together. They are going away from each other. Repelling means going away from each other. So one property of charge is the electrons will repel each other. That means unlike charges attract each other, like charges repel each other. Like charges means negative, negative, they repel each other. Unlike charges means positive, negative, they attract each other. I will tell in the next context. But you remember now, electrons are negative charged. Here also electrons in the conductor, they are also negative charged. So these negative charged electrons repel the negative charged electrons present in the conductor. Hence what happens? The electrons will start flowing. These electrons will drifted towards the positive end of the conductor. There are two ends per conductor. Okay, these electrons are drifted towards the positive end of the conductor. Hence electrons will start flowing. When electrons are start flowing, those electrons are nothing but the charges. Now the charges are in motion. When the charges are in motion, we call it as current electricity. Now the charges are start flowing, but this conducts electric current. But what happened was, when electricity or electric current it was discovered, when electric current was discovered, that time nobody knows about electrons. Means electrons were not discovered at that time. Hence, what they thought was, let us keep current from higher potential to lower potential. So they used the direction from positive cell of the battery to negative cell of the battery, or positive terminal of the cell to the negative terminal of the cell. Hence, for convention, we take the flow of current in circuit is always from positive terminal of the battery or positive terminal of the cell to the negative terminal of the cell. Whereas electron flow is exactly reverse. So to the exact reverse of the electron flow, we take the direction of the electric current, because it was earlier conventionally used that time where no electrons were discovered. That is why we use still that thing only is maintained. Okay, for convention we use positive to negative, the flow of electric current from positive to negative. So this is regarding current electricity. Okay, so after current electricity we will know about charges. I will explain this again in electric current part. So we will learn about charges. As we know, this is study of charges. We will learn about charges. What is charge? First point is, it is the intrinsic property of an atom. Intrinsic property of an atom. What is intrinsic property? See, there are two types of properties, intrinsic property and extrinsic property. Intrinsic property means inner side, extrinsic means exterior side, means outer side. So intrinsic property of an atom means, for the atom there is a property inside the atom that we call as charge. Okay, so this is intrinsic property of an atom. So when charges will happen, let me tell you. So there is NaCl. NaCl is the regular salt we use in our kitchen. Okay, Na means sodium, Cl means chlorine. So sodium chloride is the NaCl. So Na is having 11 electrons, chlorine is having 17 electrons. But in the last subshell, Na is having only 1 electron, chlorine is having 7 electrons. Due to octet structure which you learn in chemistry, Na will lose this electron and chlorine will gain this electron. It becomes 8 electrons and stable. And it becomes at the last subshell 0 electrons. That means before the subshell there will be 8 electrons. This will also become stable. So by losing the electron, Na gets positive charge. By gaining the electrons, chlorine gets negative charge. Okay, that means charge is happening only when either it has to lose the electron or gain the electron. Similarly, it has to lose the proton or gain the proton, but losing or gaining the proton is very difficult since protons are inside the nucleus. So that is why So charges usually happen by either gaining the electron or losing the electron. So thus charges happen. Since it happens inside the atom, we call it as intrinsic property of an atom. So second point is like like charges repel each other and unlike charges attract each other. Unlike charges attract each other. Attract each other. Like charges repel each other, unlike charges attract each other. Like charges in the means positive charge and positive charge, negative charge and negative charge. They repel each other. If this is positive, this is also positive. These charges will repel each other. They go away from each other. They are not coming towards each other because those are repelling. Negative charge and negative charge. Again, they are same charges. Negative, negative, same. Positive, positive, same. Means they are like charges. Again, they are repelling each other. If I take positive, negative or negative, positive, those are different charges. One is positive, other is negative. Negative and positive. They attract each other. Okay? There will be attraction between these charges. Okay? So, unlike charges attract each other, like charges repel each other. As already I explained in last, in the electricity, electrons are repelled by electrons because both electrons are negatively charged. So, negatively charged means they are like charges. Both are like charges, hence they repel each other. Okay? So, this is the second point of charge. We will go to the third property of charge. Okay, now we finish two properties of charges. We will learn third property of charge. So what is third property of charge? Okay, let me say charges are quantized. Charges are quantized. Means we can quantize the charge. That means we can add the charge. Or charges are added, we can say. Charges are quantized means we can add the charge or we can subtract the charge. If there are 4q plus 4q and plus 3q and minus 2q charges are present, then what is the total charge present in the system means you have to add this 4 plus 3 minus 2. That becomes 4 plus 3 7 minus 2 5q charge is there. So 4q charge, 3q charge and 2q charge. So in this way charges are quantized. And the last point is the charges are conserved. Charges are conserved. Means when in a total system of charges or electric circuit, the charges are conserved. Which means there is no loss of charges or no gain of charges. The total system of the charges, that means incoming charges are equal to outgoing charges. Means you cannot create a charge or destroy a charge here, but they can be conserved. In similar to the conservation of momentum, here there is no loss of charge, no gain of charge, so they are conserved. So this is the fourth point. Charges are conserved. So after this, we learn about electric current. We learn about electric current. So what is electric? So till this, I think everything is clear. We will learn about electric current. What is electric current? So as I explained earlier in last, one metal rod is there, okay, or a conductor we can say, which is connected to a battery, okay, or a cell. Cell and battery, I have to tell you, if there is only one positive terminal and negative terminal, a cell is constituted. Okay. So what is battery? It is a combination of two or more cells. Suppose if I say here, this is a cell. If I say another one, if I say another one, then this is called battery. Because one cell, other cell, another cell. There are three cells and they have to be connected. So this is combination of three cells. We can say it is a battery. Combination of two cells. That also we can say it as battery. Only this one. This is a combination of two cells. That also we can say it as battery. Okay. So in this metal or electrons are here. Okay, in a conductor. So the electrons present in this, what will they do? They repel each other, as I already told. So hence the flow of electrons will take in this direction. Sorry, this is flow of electrons. Okay, but for our convention, we take the flow of electric current in this direction. Okay, because I already told when electric current was discovered, that time there were no concept of electrons. So it is discovered later. So what scientists thought was, usually what happens, the water will flow from higher potential to lower potential. Okay. So anything that is air will flow from higher pressure to lower pressure. Similarly, what they thought, electrical current will flow from higher potential of the cell to the lower potential of the cell. So that is why they thought from positive to negative. They consider positive as higher potential, negative as lower potential. So they thought electric current will flow from positive to negative, that is higher potential to lower potential. So this is electric current. As I already explained, there is positive negative charges, electrons. These electrons will repel the electrons in the conductor. Hence what happens, these electrons starts moving. So electrons will start conducting or start moving. So electrons are charges in motion happens. This conducts electric current. So what is electric current? So electric current is denoted by I. So what is electric current? Electric current is nothing but it is the rate of flow of charges. I is equal to Q by T. When I say rate of, in physics you remember, when I say rate of, that means denominator should have time. When there is time in the denominator, then only you have to say rate of. Okay? The rate of flow of charges. Q means flow of charges. So what is electric current? Electric current is nothing but it is defined as it is the rate of flow of charges. Rate of flow of charges. Okay. So one unit time, how many charges are flowing through a particular area? That we can call as electric current. In other words, we say that rate of flow of charges. Electric current is defined as rate of flow of charges. That means it is almost the speed of electrons. Okay. In other words, you can say I is equal to Q. When I is equal to Q, if T becomes 1, if this becomes 1, I is equal to Q. Then only we can say that electric current is nothing but Q here is what? Electrons, charges. So, flow of electrons through a particular area in unit time. T is what we are taking. That means that is a unit time. Okay? So, flow of charges through a particular area in unit time in electrical circuit is called as electric current, or very easy definition, electric current is defined as the rate of flow of charges. The electric current is defined as it is the rate of flow of charges. Okay. So electric current is measured by I. Okay, it is denoted by I. So electric current is denoted by I. Okay. And electric current is measured in amperes. Okay. The SI unit of electric current is ampere. So it measured in ampere. So what is SI unit? You already know. System International Unit. In the whole world, for physical quantities, only one unit is assigned throughout the world. So that will be unit we call as SI unit. Okay, what is SI unit of electric current? Ampere. It is measured in amperes. For example, if your weight, how you say your weight? You say it is 60 kg. You say it is 45 kg. You say it is 35 kg. Means you are expressing your weight in kgs. That kg is the SI unit. Okay, for weight. Similarly, we are using here for current or electric current, ampere we are using. Ampere is the SI unit of electric current. And through which instrument we use or we measure electric current is ammeter. Ammeter is the instrument we use to measure electric current. It is used to measure electric current. So it is used to measure electric current. Okay. So how it is there? Okay. Battery will be here. See, here we connect the ammeter. So any side of this we connect the, let me say, ammeter. Positive terminal and negative terminal. It should be always connected in series with the conductor or resistor. Here we can say it is a resistor or conductor. It is always connected with the resistance or resistor. Okay, in series. Series means continuation. Means this is having continuation. That means one terminal is connected to directly to the next terminal. Means same current should flow. So that we call series. We will learn about a series of resistance in next. Okay. So here positive terminal of the ammeter should be connected with the positive terminal of the battery. Negative terminal should be connected with the negative terminal of the battery. That means cell or a battery, the positive terminal should be connected with the positive terminal and negative terminal should be connected with the negative terminal. This is regarding ammeter. Okay. Then what is the formula of current or I? That is, you already know Q by T. Okay. In this basis, we will define 1 ampere. What will be 1 ampere on this basis? See, 1 ampere, when it becomes 1 ampere, see, when it will become 1, only when Q is 1 and T is 1, right? When Q is 1 and T is 1, it becomes 1. Okay? That means I is equal to Q or 1 ampere. I is equal to 1 ampere when Q1, T1. T means time, Q means charge. And one thing I have to tell you, Q is charge means it is expressed in coulomb. Okay? I didn't tell you when I was explaining charges. Remember this. Q is expressed in coulombs. Okay? Coulomb is the scientist who discovered more on charges. That is why charges are expressed in coulombs, which are represented as C. The SI unit of charge is C. Don't forget these two things. It is expressed in coulombs and the SI unit of charge is C. Okay, let me define 1 ampere of current. The current is said to be 1 ampere. The current is said to be 1 ampere if 1 coulomb of charge flows in a circuit for 1 second. 1 second, 1 coulomb and 1 ampere. That means current is said to be 1 ampere if 1 coulomb of charge flows in an electrical circuit for 1 second. Okay, let me write that. This is the last concept of this class. What is 1 ampere of current? Current is said to be current or electric current. Whenever I say current, that means electric current. Current is said to be 1 ampere if 1 A is 1 ampere. If 1 coulomb of charges. 1 coulomb of charges flows through a circuit, flows through a circuit for 1 second. That is the formula I is equal to Q by T. When T becomes unit, Q becomes unit and I becomes 1. That is unit. So this is I is equal to Q by T. So hence the class what we learned, what is electricity, types of electricity, and where static electricity used, where current electricity is coming, okay, properties of charges and SI unit of charge. Don't forget I told last, SI unit of charge is coulomb and the charges are expressed in Q. Okay, SI unit of charge is coulomb. Okay, then after that electric current. Okay, what is electric current and the formula for electric current, SI unit of electric current, the instrument used to measure the electric current. These all we learn. And lastly, what is defined 1 ampere of current? Okay, current is said to be 1 ampere if 1 coulomb of charge flows through a circuit or electrical circuit for 1 second. So this is regarding electric current. So we will learn about what is potential difference and other things in the next class.